Right.
Whoa, yeah.
So, would it be PB3, parentheses with the 4?
Yes. Good. Good. Very nice. Excellent. It doesn't get any harder than that. That's about as hard as it gets. Yeah?
So are there ever numerals in the, like, that?
Are there ever Roman numerals in that parentheses?
No.
Or
Only with metals.
No, like, with the, like, how lead is in there, so is there, when it's, never mind.
Could be lead 3, could be lead 5, could be lead 6.
But would the parentheses with the numerals be in that form ever?
Yes. I think if I understand your question, because there's two ways, there's two types of questions she'll ask you. She'll either give you the name and ask you for the formula, or give you the formula.
Can we do that way, please?
Yes, and ask you for the name. Is that what you're asking me? No, but thanks for sharing.
If the numerals would ever be in the formula?
No.
No,
Okay.
no, never, never. Because what does the Roman numeral really mean? It just means
This means the
positive charge for the metal.
already in there.
right.
And-
It's already accounted. Very nice. It's already accounted for.
And could it ever be a negative charge with
No.
metals?
It's all no. Metals are always positive.
Negative
Test-
That'd be funny.
Test question alert. The charge on metals is always
Positive.
positive. Never negative. Metals are always what?
Positive.
Positive. Are you positive?
positive.
You
Yes.
must be a
Oh,
metal.
shoot.
Right. Thanks. Okay. Drum
What,
roll.
sir?
Rim shot.
Sir, what?
And this one will be-
But non-metals are not always negative.
Good point. Non-metals are usually what?
Usually negative, but sometimes positive.
Exactly. Very good. Jessica has a fine eye for detail. You hear what she said, Val? Non-metals are usually negative, but some are sometimes positive. But metals are always
Positive. Because Cal's positive and he's a metal.
Yes, bad.
okay.
Sir, please.
I have a problem.
All right. Two special routines on flip, flop, and drop. First one is magnesium oxide. So when we do magnesium oxide, we get Mg plus 2, O minus 2. When the charges are the same, you don't need to flip flop, you just drop. When the charges are the same, opposite, same number, opposite charge, you don't need to flip flop, you just drop. So it's not Mg2O2, wrong, it's MgO. Everybody okay with that?
Did you say that when you're doing that with the, like the PO4, you don't need the parentheses anymore? If they cancel.
I see. So if I had Al PO4
Yes.
and it was minus 3 plus 3,
Yes.
I would just,
You don't need the parentheses?
Right.
Okay.
yeah, you don't need the parentheses unless there's a flop.
Okay.
And if we're not flopping,
Because otherwise you just put parentheses 1 on the outside and that would
yeah, and yeah, even if you flop with the 1, it's like, well, it's like, what is that? That's 1x, isn't it? Do I have to like write 1x or like, are we among friends?
We're a monk.
Exactly. Okay, so rule number 2, possible little tiny exception, just watch out for it,
My friend.
would be this one. 10-4 oxygen. 10 Rome 4 oxide.
And for oxygen, maybe 2.
So 10 is SN, go figure. What's the charge?
Positive.
Positive what?
What?
Positive what?
Positive 4?
Yeah. And oxygen is?
Negative.
Okay. So what do you think the answer is going to be? Sin 204?
No. Yes. No, it's because the 4 and the 2, it just seems like that just should
They can
be.
cancel.
Exactly. They're like multiples of each
One
other.
becomes 1
Yeah.
and the SA
Spice Girls, 2 becomes 1, exactly.
Oh,
So,
that's true.
That is such a great song.
So instead of 2, 4, we just go 1, 2. So what if it happens that they end up multiples of each other, which is rare? A 2 and a 4 and a 3 and a 6 is all you'll ever see, and it's rare you even see that. Just remember you have to reduce it down. So it would really be 10, 1, 0, 2, and that's it. So those are the two exceptions, right? If the charges are the same, just drop, don't flip, flop. And if they're multiples of each other, then don't flip flop, or do flip flop, but then reduce before you drop.
Everyone likes reducing.
Yeah. Got that, Val? Pay attention, Val. Wake up.
I'm sure she
Sleepy.
reduces.
Okay, so, okay. Turn off the music, Val, and keep the TV off too. So, what else do we have here? Anything else?
Let's do
Okay.
ones where we see it in the form and then we have to
Like
convert
translate it back.
Okay, so you want to see like the formula, and then you want to do the
that's
longhand.
what I want to do.
Okay. So here we go. So we'll do. What's below magnesium?
Mag dog would be calcium.
Cool. So we'll do calcium.
Cal. Sorry. I have a problem.
To show up that time.
Oh.
Okay, so just work this one backwards.
So it'd be calcium and S.
Oh, so you're doing flip flop and raise.
Actually, no, I don't have to at all. All I do is the only time I have to do reverse flop is when it's a transition metal. As long as it's not a transition metal, no reverse flop required. Just name that tune. What's that called?
Calcium.
And what's that called? Look on your little polyatomic ion chart.
Something like
Sulfate.
sulfide.
So the answer is calcium.
Sulfate.
End of story.
And what's the charge?
We don't care.
Yes. Yes.
We don't care. Working backwards, the only time we have to care about the charge is when we have a transition metal. So, is that a transition metal?
No.
So working backwards, the first thing you'll ask yourself is, you just look at the first metal and say, is it tranny or not? If it's not a tranny, then don't worry about charge. So this calcium sulfate. Now what if it was SO3? You go calcium sulfite, because that's what it says in the chart. You look in your little polyatomic ion chart, it says SO3 neg 2, right? And it says sulfite. Okay? Now, what about this one? What if you have CrSO3? You look at the first one, it's a metal. Is it a tranny?
No.
Yes.
CR?
Well,
CR,
it's-
yes, it's definitely.
So what does that mean you have to do? Now you have to reverse flop.
No.
Chromium 3?
No, what's the charge in SO3?
1. It's
No,
1.
look at your poly.
Oh my god, so
Look at your poly chart.
Negative 2.
Say again?
Negative 2.
Negative 2.
You and your stupid
So
head.
if that's negative 2, what does the chromium have to be to make that neutral?
2.
And how do I show that when I write it out longhand?
The Roman numeral 2.
Right, so
Let's
this would
do
be
another one that-
chromium, parentheses, Rome 2, sulfite.
Fight.
Is everybody with me on that?
Let's do another one.
Everybody will miss that. Everybody will miss that in the test. Everybody, except you guys,
Because it just
will miss that in the test.
doesn't go over that. God. Another one, probably. Another.
How about up here? Okay, so let's do.
Let's do gold. I like gold.
Okay, AU.
Chromate.
AU.
Chromate.
Okay, AU. So
CRO.
CRO 3 or 4.
3, 4,
What about Taylor?
4, 4.
Okay. AU CRO 4.
Okay, so we're just gonna reverse it. And so it has a negative 2 charge, and so
What has a negative 2 charge?
the
Chromate.
the chromate. And so we put that onto the top.
AU2.
But don't say AU. Say you got to write it out. How do you-
AU and
how do you write
then
AU out?
parentheses,
Gold.
Gold 2. Oh, okay, that was easy.
Chromate. That's chromate, Val. Gold 2 chromate. Does that make
It
sense?
has a 2 charge.
Sorry.
Has a positive 2 charge.
In this case, gold could have +1, +2, +3, +4, right? But because it's with chromate, which is a -2,
Mine's 2.
it has to be +2,
Right.
and you show it right there. Because you never know what the transition metals are going to be. They always change from
They're always positive.
from incident to incident. They change. They could be +1, +2, +3, +4. Depends on what they're with. But they're always positive. All right. So now, she may ask you about this. She may say, this is kind of a stupid question, but it may come up. You should just know this. The difference between these two. This one is called chromate. This one's called chromite. The difference, technically, between 8
She would ask this.
and
I
ite
wrote it down.
It's in the notes.
is that the 8 has more oxygen and the ite has less oxygen. So you can only do these in comparison to each other. And you can also do a stupid thing to remember it. You can say, I can't believe I ate the whole thing. So it had to be bigger because you ate the whole thing. So 8 has more oxygen. Ite has fewer oxygen. So she could do something dumb like this. Not dumb, devious. She could go
Devious.
XO2 minus 1, A, XO minus 2, B, C, XO3 minus 2, and D, XO4 minus 1. And say, which of these is called 8?
C.
D.
Oh.
How come? It has the
4.
most oxygen.
Damn
So
it.
whenever you have the same form, whichever one has the most oxygen is the 8. Whichever one has the second most is the
Ite.
ite.
Oh, not the least most?
No, second most. Ite. You won't have, there's nothing below the least most. There's nothing below the second most. There's no third most or least most. So it's either the most or the second most. But there's no suffix for third most or fourth most.
Okay.
Only the first two.
So then the 8s and ites can change.
Well, yeah, it could be, for example, if I had these two things, what's this one called?
Ite.
Nitrite, and this one's called nitrate.
Nitrate.
How come? Because it has more O's. So it's all relative. You really have to see them in combination with each other.
Yeah, so then the next one, like if there's another question, it could be O with the 3 could be called nitrite and the, okay.
And O with the 4, if she gave you only, would be nitrate.
Okay.
Yeah? So it's kind of a fluid kind of scenario. Okay.
Oh,
Does she have oxalate on that chart? That's a weird one.
what's
Yes.
it?
Okay, so let's do aluminum oxalate for me.
Oh yeah, there it is.
Aluminum oxalate.
Three. Oxalate. -2.
Aluminum oxalate. What is oxalate?
C2O4 Chinyag.
Cal, you want to do it?
Do it, Cal. Do it.
Okay. So that'll be Al2 parentheses
Oh, yeah.
C2O4 mother parentheses 3.
Nice.
Yay!
Yes.
Okay. Now, if you look at that chart, you'll see that almost all the polys are negative, correct?
Correct.
But there is one very important TQA
The
positive
+1,
poly.
Ammonium.
Right. So guess which poly comes up more often than any other poly?
Ammonium.
Exactly. How come?
Because it's
Positive.
positive.
Because all the other ones are negative. So she makes a big deal about that. So you need to remember that ammonium is positive. Now, so far, in all of our compounds, which came first, the positive part or the negative part?
Positive.
Positive part. The metal came first because it was positive. Well, NH4, because it's positive, even though it isn't a metal, it still comes first. It still comes first.
With this bond.
So, can we have ammonium with a metal?
No, no two positives.
No two positives. Exactly. So you can't have a metal with ammonium. Can you have ammonium with a non-metal?
Depends on which non-metal.
True. And can we have ammonium with another negative poly?
Yes.
Yes. So here's your two examples of ammonium.
Oh, the backside of that one's. But
Yeah, but I can't get to it.
yes.
Right there. Beautiful
Okay.
spot.
So,
Stupid top.
ammonium hydroxide. Ammonium hydroxide.
Ladies and gentlemen, ammonium hydroxide has left the building.
Oh goodness. That's easy.
And then, so Jessica, what do you got for ammonium hydroxide?
NH4OH.
Exactly. Everybody okay with that? NH4OH? Plus 1, minus 1. We're done. Now, working backwards on this one, Taylor, what's NH4 parentheses 2O going to be called?
Ammonium something oxygen?
Yes,
Oxide?
yes, yes. Now, if oxygen just by itself, it's just going to be oxide. It's going to count like a binary compound, so it's going to be ammonium oxide.
Is that a common one? She was droning about something being common with ammonium and I just wasn't paying attention again.
Could be a halogen with ammonium.
Never mind.
Could NH4Cl, NH4F,
Yeah.
or you move one column over, NH420, NH42S. Yeah. Okay.
It's a pretty lame chapter.
Hold on, I'm sure I had some questions when I was reading.
It's not a very difficult chapter, but it's very important because this is like this chapter and the next chapter are the fundamentals of chemistry because they all talk about chemical bonds.
We read a lot for this chapter, not meaning much.
So what do they start with in the
Cations, anions, electroneutrality.
anions and cations? What's a stupid way to say positive charge?
Cation.
What's a stupid way to say negative charge? So anything with a negative charge is called a anion. Anything with a positive charge is called a cation. And in fact, I rarely use those terms ever, but know them for the test. Then also you should know from that first section of the chapter, they give two examples of ion formation. They show loss of electrons, and they show gain of electrons. So you should know these two patterns. They show Li goes to Li plus 1, and this means lithium is neutral as an element. It wants to lose one electron, so you put the electron on the right side because that's where loss occurs. Loss means right side, gain means left side. If the electrons are lost, you put the electron on the right side. If the electrons gained, you put electrons on the left side. Now, when it's lost, does the element become more positive or more negative?
Positive.
It becomes positive. So this represents loss of electrons. And what energy was associated with loss of electrons from last chapter? What's the name of these compounds?
Endothermic.
What was the name of these compounds? What kind of compounds are they?
Ionic compounds.
Ionic compounds. What energy is associated with
Ionization energy.
ionization energy, formation of ions? So if you lose an electron, you become more positive. This represents ionization. Then the flip side of this coin is fluorine. Does fluorine want to gain or lose electrons?
Floor dog wants to gain.
Florida.
1.
And gain would be on the left side or the right side?
It would be on the left.
So it gains an electron, put it on the left, put an arrow now, and then what does it become when it gains an electron? More positive or more negative?
Negative.
And then what was the energy associated with adding an electron from last chapter?
Dude, you got the A. Speak up.
Yeah.
It would have to do with an attraction or an affinity.
Oh, electron affinity.
Electron affinity. So this is ionization energy example, And this is an example of electron affinity. Ionization energy, you lose an electron, show loss on the right side, and the element gets more positive. Electron affinity, show gaining an electron goes on the left side, gain means left, and you get more negative. So this just shows the internal dynamics of what happens to each of the individual participants in the bonding couplet. One of them loses an electron, the other one gains, right? Your loss is my gain, says fluorine to lithium. Therefore, let's stay together. And two become one. Lithium fluoride, Spice Girls, have fun. And that's the name of the game. Ionic compounds. One loses, one gains. Okay, what else is in that first section that I haven't talked about?
Electron neutrality.
Well, they zap to neutrality once they combine.
Isoelectronic.
Good point. Isoelectronic. So, the way to remember isoelectronic is just this scenario. Fluorine, negative, neon, neutral, and sodium, positive. Can anybody do the electron configurations? Why don't we just go across the board? Cal do the first one, Taylor do the second one, Jessica do the third. Give me electron configurations for these ions and that noble gas.
1s2,
Oh no!
2s2,
Okay.
2p6.
Very nice.
Oh wait, just kidding. What's
Taylor, you're up.
1s2, 2s2, 2p6.
Nice. Jessica?
neon in brackets and S1.
Just got the hard one.
Oh.
Jessica? It's +1.
Oh. Yeah.
So what does that do?
That would be 2s2. What am I
Just do
doing?
the whole thing.
1s2.
1s2.
2s2.
1s2.
Then you go to that.
2s2, 2p6.
Are you sure?
Yeah.
Okay, now what do all these three have in common?
They're all different.
Helium.
Damn it.
What do they all have in common? Look at them.
6
Look.
p6.
1s2, 2s2, 2p6. 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. What do they all have in common? The same
Number of
electron configurations. What do we call it? Fancy word for the same electron configurations.
Isoelectronic.
Isoelectronic. So these three are all isoelectronic. Do you see why they want to be isoelectronic? They all want to be isoelectronic to a noble gas by either losing or gaining electrons. Okay? This is like the key to chemistry right here. To understand that they have charges to get the same noble gas-like electron configurations. S2P6, S2P6, S2P6.
Valence. Oh, wait.
Octet, octet, octet.
Oh, octet is the valence.
Is there a
Yeah, the octet rule.
octet rule?
The tendency of atoms of elements to gain or lose electrons so that their outer s and p orbitals are full with 8 electrons.
Outer S and P. Did we say inner? No, just outer, outer, outer. The inner are always filled, so we don't care about them. It's the outer ones that want to be filled. The inners are always filled by default, so it's like, well, who cares? But the outer ones, now there's where the chemistry actually occurs. Okay, so do we have to know what valence electrons are, Jessica, in this chapter?
We learned about them last chapter, right?
I don't think so.
Oh. I thought they were just the S and P.
They are. The S and Ps. Very good.
And there's like, you can go by group number, but you can
Yes,
skip
good.
them.
You guys are very good. So if you just look at the top of each column, there's a group number, right?
Mm-hmm.
And if you just look at the group number, that's your valence electron number. What if it's a teen?
Then you drop the 1.
Drop the 1. Good. So Taylor, tell me what the valence electron number is for the nitrogen column.
Nitrogen
1, 2, 3, 4.
5.
5.
Thank you.
Thanks, Jess. Okay. It was 5, Al. Okay, it's a high. All right, what else, Jessica, for that chapter? Oh, structure. Structure
Yeah, that
of
one.
ionic compounds?
Yeah.
Remember the structure last? Did we talk about the grape,
No, but I
the
really
oranges?
wish we did. Oh yeah, we did the lattice.
The crystal lattice?
Yeah.
The stripper? Yes. So, same kind of structure for ionic compounds. They have a crystal lattice structure. So do ionic compounds have high melting and boiling points?
Yes.
Very high melting and boiling points. How come? Because they have a crystalline structure like metals. What else is in that first section, Jess?
Well, we finished the first section.
Okay,
And then
moving on.
there's the crystal structures of salts, depends on the size of
Oh, salts. By the way, if we say, what's the most common kitchen ionic compound? NaCl, otherwise known as salt. Well, it turns out street name for any ionic compound is salt.
Mm-hmm.
So all the compounds we've been doing today have all been what?
Salts.
Salts.
Exactly.
Salty goodness.
Even with polys. A metal with a poly is a salt. So the fancy name is ionic compounds, street name,
Salt.
salts. Okay. So, hey man, I got any salt? Yeah, okay. So there it is. Salts.
Yeah.
And
Salt.
What's a coulombic force? Or
cool,
Yeah.
good point. This is a stupid way of saying positive and negative attraction. To make it as difficult to understand and as complex, as unnecessarily complex as possible, she'll use the term, what causes ionic compounds to stay together? And instead of the answer being positive and negative attractive forces, you'll need to say coulombic force.
That's so stupid.
And then there's
Exactly.
halides.
Halides just means the compound that ends in a halogen. So if you have sodium chloride, it would be a halide salt. If you had sodium fluoride, it would be a halide salt. What kind of compounds in an ide? Test question alert. How many wheels in a bicycle?
That's binary compound.
2. So binary compounds end in ide. Are there any exceptions? Yes, there's a polyatomic ion that ends in ide. Go figure. Hydroxide. It's like, well, that's not binary because it's a poly. But in general, binary compounds end in ide unless there's a polyatomic ion that ends in ide, in which case it's not a binary, it's a poly.
Excellent.
What else? Keep going, Jessica.
Unit cell.
Unit cell.
The simplest repeating unit of a crystal lattice.
Sometimes teachers really get carried away. If you thought coulombic force was bad, watch this. If I have a crystal lattice structure, which means I've got like a little matrix deal, and in the matrix there's all these little lines. There's a sodium and a chloride, sodium and a chloride, sodium and chloride, sodium and chloride, sodium and chloride, like next to each other all the way through here. What forces hold those together?
The
Coulombic forces. And then the bizarre question. Would be, if they're all NaCls, NaCls, and